Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to discuss about the inter-process communication between processes known as IPC. What are the needs of the process cooperation and how we can achieve them to process communicate. Processes that are executing concurrently in the system can be of two types. One is independent process and another is cooperating process. What is an independent process? That the process is not affecting or not getting affected by other processes. They do not share any memory data. Now for cooperating processes, a process can affect or get affected by any other process because they are sharing the actual data and information and address space of other processes. So in terms of cooperating processes, we need a method to communicate in between them. That method is known as inter-process communication or IPC. So what are the needs for cooperating processes? The first one is information sharing. Maybe that one or two more processes may need to share or access to the same piece of information. The sharing the information is very important between the cooperating processes. Next is the computation speed up. The computation or the performance of a system can get rapidly speeded up if the task is divided into different subtasks which can run in parallel in the exact system. So this can done in the cooperating processes only with the computer with a multiprocessor architecture. Next one is the modularity. What is a modularity? That the incorporating processes can incur or increased and reliable modularity to the system that gives defining the system function into several components and then again run them in the parallel section. The last one is convenience. It is possible for a user to make many tasks at a time, like listening to music, compiling a table, and writing to a data structure. This can be done with a convenient and cooperating process only. Now the cooperating processes that we have mentioned can communicate with each other in two different mechanisms. One is shared memory, another is message passing. In shared memory, there is a region of memory area that can be established as a shared one, and the data and the information can be read and write by the cooperating process in terms of sharing them. By sharing the information, the processes can communicate with each other easily and readily. In the message passing system, the messages or packets of blocks of information can send by the user process and be received by another user process in terms of indirectly and directly. Here we will see that how these two processes methods can be done in communication. Here in the message passing system, we are considering two processes, process A and process B. They are communicating with each other. Here we can see that there is a message queue and a queue of messages like from M0 to Mn. If process A is accessing a message 0 and the process B is accessing a message N, then they can send and receive number of N messages in the communication process. Now we will see that how that is done in the shared memory method. Here in the shared memory section, the process A and process B both are communicating. First, the shared memory area in the process memory system first established, then the process can read and write into the shared memory section to exchange information between them. and the kernel is residing at a different space for this shared memory section. I'm sorry. And the kernel is here residing in a separate section for the shared memory model. Now, both of these models are common in designing the operating system and can be implemented in the operating system as separately. Now, the message passing system is good and easy to use for smaller amount of data communicating with each other, as no conflicts needed to be avoided. The message passing system is good in the distributed system than time sharing or shared memory model, that it is not sharing in memory and the connected network can be different computers processes can communicate with each other. Shared memory has faster access than this message passing model, as the message passing model only can execute to the system calls and thus involving the kernel a very much again time consuming section. This time-consuming section of the kernel and intervention of the kernel makes the message passing model much slower than the shared memory, when then the system call is only for establishing the shared region, and after that, without any intervention of the kernel, the processes can read and write information in the shared region, thus making it very faster. But if we are gaining more processors into a computer architecture, then message passing model is surely a better one than the shared memory, as it contains a cache coherency. What is a cache coherency? The shared model that there can be shared messages in the many caches in the many processors in a multiprocessor architecture. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.